let's see another example in AC circuit to verify reciprocity theorem. So this is the circuit. Here we can have one independent voltage source having value 200 angle 45. Let's say this is branch A and this is branch B. Here excitation is connected in branch A and response is the current through branch B. This type of network is known as ladder network. So in order to solve this type of problem, we need to consider these mesh currents. In this network, we are interested in finding out the value of mesh 3 current, that is I dash. How to find out I3 or I dash? It is del 13 divided by delta. In mesh analysis, we will write the equation like this. Here we can see impedances are available. So here Z11 stands for the impedance available in mesh 1. That is the total impedance of mesh 1. When we are considering mesh 1 alone, the total impedance is coming as 20 plus J10. Then what is Z12 and Z13? Z12 is the impedance common between mesh 1 and mesh 2. Here it is J10. Then how to fix this negative sign? For that, let's consider this current direction in mesh 1 and mesh 2. When we are considering a particular mesh, that mesh current need to be taken as positive. So when we are considering mesh 1, I1 is positive. If I1 direction through J10 is equal to I2 direction, then we can take J10 as positive. If I1 direction and I2 directions are opposite, or in other words, if I2 direction is opposite to I1 direction, we can take the sign for J10 as negative. In this case, we are considering mesh 1. Therefore, I1 is taken as positive. I2 is opposite. That is, I1 is falling down. I2 is going up. I1 and I2 are in opposite sign. Therefore, this value is minus J10. So, this matrix, that is denominator matrix, is just the coefficient alone, that is Z11, Z12, Z13, Z21, Z22, Z23, Z31, Z32, Z33. So when we are writing this coefficient alone in matrix form, that is this matrix. Let's see how we got this matrix. First of all, let's consider these diagonal entries. Diagonal entries are the sum of impedance in respective mesh. When we are considering mesh 1, the total impedance in mesh 1 is 20 plus J10. That is coming. When we are considering mesh 2, the total impedance is 20 plus J10 minus J10. This J10 and minus J10 will cancel. So the total impedance is coming as 20 ohm only. When we are considering mesh 3, the total impedance is 10 minus J10. In this way, we can write diagonal entries. Coming to off diagonal entries, we need to consider current direction. When we are considering mesh 1 current is positive and mesh 2 current, we need to check. Here I1 and I2 are in opposite direction. So this sign is, that is Z12, the impedance common between 1 and 2 mesh is. Similarly, there is no impedance common between mesh 1 and mesh 3, therefore it is 0. When we are considering mesh 1, the voltage is 200 angle 45. Here V1 becomes 200 angle 45. In mesh 2 there is no voltage, therefore V2 is equal to 0. Then what is the impedance common between mesh 2 and mesh 1? When we are considering mesh 2, we will take I2 as positive. Therefore I1 is opposite to I2. The sign of this impedance which is common to mesh 2 and mesh 1, that is Z21. Z21 become minus J10. Then total impedance we got it as 20, and the impedance common between mesh 2 and mesh 3 is minus J10. When we are considering mesh 2, I2 is positive, I3 is opposite. So minus J10, that becomes J10. So When we are considering mesh 3, the voltage in mesh 3 is 0. Here V3 becomes 0. And the impedance common between mesh 3 and mesh 1 is 0. Then impedance common between mesh 3 and mesh 2 is minus J10. As the current direction I2 is opposite to I3, the sign is minus of minus J10, it becomes J10. And the total impedance is 10 minus J10. So in this way, we can write this matrix. So for that matrix, we need to determine the determinant that is denoted by delta. Then now let's discuss how to obtain del 1 3. In order to find out I1, here we need to consider delta 1 1. In order to find out I2, we need to find out del 1 2. Similarly, in order to find out I3, we need to find out del 1 3. In order to obtain del 1 3, we need to replace this column entries of this matrix with voltage sources in each loop. Here V1 only is having value, that is 200 angle 45. Remaining loop voltages are zeros. So after obtaining this determinant and this determinant, we can obtain the current flowing through branch B at 2.16 angle 57.5 ampere. Now in reciprocity theorem, we need to remove this voltage source from branch A and we will connect this voltage source in branch B. Then due to the application of this voltage source, we will find out the current flowing through branch B. Here let's consider we are connecting voltage source in this manner. Due to the application of this voltage source in branch B, a current will flow in branch A. Let's call that current as I double dash. If I double dash become equal to I dash, we can say that the network is reciprocal. Here it is to be noted that excitation is in B and response is in branch A. Let's rename the mesh current as I1 dash, I2 dash and I3 dash. Here it is to be noted that due to the change in direction of this voltage source, I1 dash, I2 dash and I3 dash, let's take in this direction. Here also we need to find out delta 1 1 and delta. So delta matrix is very simple. It is the impedance matrix which is obtained by considering mesh equation. The determinant of that matrix gives delta. Then how to obtain delta 1 1? In order to find out mesh 1 current, we need to replace the first column entries of this matrix with voltage sources available in respective mesh. In mesh 1, voltage source is 0. In mesh 2, voltage source is 0. In mesh 3, the voltage source is 200 angle 45. So when we are replacing these entries with this voltage source, we can obtain del 1 1. And after solving this one, we can obtain the answer as 2.16 angle 57.5 ampere. As I double dash is equal to I dash, this network is reciprocal.